what I've got for you now is still a fairly simple momentum problem, and not as many zeros as the first example, but still I would call this an easy problem. Going to solve it both ways, both with the conservation of energy equation, kind of with the mathematical, blah, 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 keeping it all straight, and then with the table method. Our problem. During a goal line stand, a 75 kilogram fullback moving eastward with a speed of 8 meters per second collides head-on with a 100 kilogram lineman moving westward with a speed of 4 meters per second. The two players collide and stick together, moving at the same velocity after the collision. Determine the post-collision velocity of the two players. Okay, so we've got two people heading at each other, and then they collide and stick together. So we've got one person moving eastward and one person moving westward, and then in the final condition they stick together and we don't know which way they're going, do we? We don't. It didn't say. So are they going this way? Are they going that way? I don't know. Let's get the numbers. This, the one moving east was 75 kilograms, and the velocity was 8 at 8 meters per second, and that'll be positive because we're going to the right, east. And this one was 100 kilograms at 4 meters per second west, so I'm going to put a negative sign there. Okay, so I'm not sure which way they're going to go. We can make a guess, or we can just let the math figure it out for us. Whichever. Okay, we've got initial looks like this, final looks like this, and we also know that since they stick together, the velocity of, how am I going to say this? Let's just call it person A and person B. Final. Final velocity is the same because they stick together. All right. What are we looking for? What's the post-collision velocity? That was it. Oh, let's just do that. What's the final velocity? Okay. If we look at this from conservation of momentum perspective, I can say, okay, P initial equals P final. Initial, I have two objects, they're both moving. So that's going to be P initial A plus P initial B equals P final A plus momentum final B. Okay, what do I know? So this will be mass of A, V initial A, plus mass of B, V initial B. Whew, all these subscripts. Mass A, V final A, and mass B, V final B. Keeping track of subscripts is going to be the key to solving these problems. Are there any zeros? Nope. 4 terms to deal with then. We know the masses, and we know these two, and we're looking for that. That looks like 2, but it's not really 2. There's only 1 because those are the same thing. So let's put the math together. Mass of A. Okay, I should probably make sure I'm being consistent here. Mass of A is 75 times velocity of A plus 8. Mass of B is 100 times velocity, negative 4, equals mass A, 75, V final A, plus 100 times V final B. And because these are the same, I'm just going to pop those together and say that's 75 plus 100 times V final. Do we know everything? We do. We do know everything. So at this point, get a calculator, try the calculations, and we know everything but V final, and see what you get for V final. And don't forget to watch for a negative sign, because if it's positive, they're going to the right. If it's negative, they're going to the left, and I don't know which one is correct. I have a suspicion, because the speed was off by a factor of 2, but the mass isn't off by a factor of 2. So if I had to make a guess, I'm going to guess this person wins the push. I don't know what to call it. What do I get? What do I get? What do I get? I get an answer of positive. Yep, so I guessed right. 1.1 meters per second. And again, check your answer. I guessed to the right, so the sign, yeah, I'm going to go with that. 1.1 meters per second. Would it make sense that the speed of them combined is less than the speed of either of them to start with? Absolutely. You've got one going this way, one going this way, they stick together. They're not going to be going faster than either one of them started, so a pretty small number for the velocity looks correct. So 1.1 meters per second, and they end up going that way. So that is the kind of mathematical equation method, and let's do the table method next. Okay, so here's the table set up. We've got a column for initial momentum, we've got a column for final momentum, we've got object A, object B, and a row for total. Let's fill in what we know. The initial momentum of A would be mass times velocity. Do we know the mass? Yes, 75, and we know the velocity is plus 8. What does that come out to be? Plus 600. Oh, I could have done that in my head. Initial of B, 100 times -4. You can do that one in your head. -400. P final of A is going to be 75 times V final A. And this will be 100 times V final B. Okay, add them up. 600 minus 400 is plus 200. That has to equal plus 200 over here, because initial has to equal final. And at this point I say, oh, okay, so now I can add up this column. I've got, let's see, down here, 75 times V final. And I know these are the same, so I'm just going to say, it's V final, plus 100 V final equals 200. So add them all up, has to equal 200, which means we have 175 V final equals 200, and if you do the math, you should get 1.1 meters per second positive. So here is the table method. Again, whichever method makes more sense to you. I don't really care which way you go. If table makes more sense, use that. If just writing out the equation makes more sense, use that. They both get you the same answer. So here's another easy problem with the two different methods. I hope this was helpful.